ওকে, আমি কি শুরু করবো নাকি ভাই আপনি কোনো ফার্দার?
রিফাত একটা কিছু বলুক।
সবাইকে ওয়েলকাম আজকে আমাদের বুয়েট এসএম চ্যাপ্টার আর সিএসসি বুয়েটের টকে। আজকে আমাদের স্পিকার সৈয়দ রাফিউল হোসেন। রাফিউল এখন অ্যাসিস্ট্যান্ট প্রফেসর হিসেবে আছে ডিপার্টমেন্ট অফ কম্পিউটার সায়েন্স এন্ড ইঞ্জিনিয়ারিং, পেনসিলভেনিয়া স্টেট ইউনিভার্সিটি। রাফিউল হলো আমাদের 2003 ব্যাচের গ্র্যাজুয়েট। সো রাফিউল আমাদের এখানে গ্র্যাজুয়েশন শেষ করে পরে ও পিএইচডি করে হলো পার্ডু ইউনিভার্সিটিতে পিএইচডি করার পরে সেখানেই পোস্টডক হিসেবে বেশ কিছুদিন কাজ করে এবং এরপরে এই বছরই সে জয়েন করলো পেনসিলভেনিয়া স্টেট ইউনিভার্সিটিতে। রাফিউলের রিসার্চ ইন্টারেস্ট মেইনলি হলো নেটওয়ার্ক এন্ড সিস্টেম সিকিউরিটি। মেইন ফোকাস হলো সিকিউরিটি এবং প্রাইভেসি অ্যানালাইসিসের মাধ্যমে মানে বিভিন্ন ইমার্জিং নেটওয়ার্কস এর এই অ্যানালাইসিস গুলো করা। তো রাফিউলের বেশ কিছু ভালো পাবলিকেশনও আছে। রাফিউল আবার মানে আমার তো অনেক আগের থেকে পরিচিত। রাফিউল আর আমি একই ক্যাডেট কলেজে ছিলাম, মির্জাপুর ক্যাডেট কলেজে। খুবই হার্ড ওয়ার্কিং ছেলে, মানে আমরা ক্যাডেট কলেজে থাকতে মানে অনেককেই বলতাম আর কি। সো রাফিউল মানে অ্যাজ এ ছোট ভাই আমি রাফিউলের গ্রোথটা আসলে একদম সেই ক্যাডেট কলেজ থেকে দেখছি। খুবই হার্ড ওয়ার্কিং ছেলে এবং মানে ও আসলে এখন যেই অবস্থায় আসছে সে একদম ট্রুলি সেটা ডিজার্ভ করে আমার বলে মনে হয়। রাফিউল, তোমাকে থ্যাংক ইউ আমাদের টাইম দেওয়ার জন্য। তুমি স্টার্ট করো তাহলে।
থ্যাংক ইউ রিফাত ভাই। মানে দিস ইজ এ গ্রেট অপরচুনিটি ফর মি। থ্যাংক ইউ রিফাত ভাই, আতিফ ভাই and everyone. রিফাত ভাই আসলে কাইন্ড অফ আমি ক্লাস 7 থেকে রিফাত ভাইকে চিনি। ইনফ্যাক্ট আমি রিফাত ভাইয়ের টু বি অনেস্ট রিফাত ভাইয়ের ক্লাস 7 থেকেই হচ্ছে বলতে গেলে বা ক্লাস 19 থেকে রিফাত ভাইয়ের নোট করে পাস করে আসছি। সো রিফাত ভাই কাইন্ড অফ আমার কাছে লিজেন্ড টাইপ মানুষ। আতিফ ভাইরাও হচ্ছে, আতিফ ভাইদের সাথে পরিচয় অনেক আগের থেকে, মানে বুয়েটে আমরা একসাথে উত্তরা থেকে বাসে করে যাইতাম, বুয়েটের বাসে। তো আতিফ ভাইও হচ্ছে ওয়ান টাইপ অফ লিজেন্ড আমার কাছে। আর স্পেসিফিক্যালি আমি শিওর যে রাজীব ভাই সবার কাছে পরিচিত, খুবই ফেমাস মানুষ। রাজীব ভাই যদিও নাই, বাট ভালো হইতো রাজীবের সাথে কথা বলতে পারলে ডিরেক্টলি। সো মানে
রাজীব ভাই আরেকটা মিটিং এ আছে, আমি রাজীব ভাইকে জানাইছিলাম। রাজীব ভাই রাফিউলের টক আছে, আসবে বলছিল পারলে।
আর স্পেসিফিক্যালি আমি আশিক স্যারের কাছে খুবই কৃতজ্ঞ, কারণ আশিক স্যার হচ্ছে আমার থিসিস অ্যাডভাইজার ছিলেন বুয়েটে। সো উনি মানে উনার কাছ থেকে আসলে আমার রিসার্চের হাতে খড়ি। কাইন্ড অফ from there actually I didn't have to stop. And whatever I kind of achieved from there, that is kind of unimaginable. Like, I mean, the passion for research. So mane Ashik sir, awesome, simply awesome. Anyway, so let's get started. So today I'm going to talk about automated reasoning of security and privacy of networks and cyber physical systems. So before going to the details of my talk, let's first see that what happens when we have when we design any complex network protocols or systems. So most of the time we have seen that when designing such complex systems, security is considered afterthought. Like it is considered after ensuring the functionality and performance of the systems. For instance, when first generation cellular network was designed, it was meant to provide basic functionality, that is long range over-the-air communication between two devices. Security was not considered at all at that time. And in fact, until 4G, there was no mutual authentication between two devices or between device and the network. In case of IoT, we have seen that it has enabled us kind of controlling our handheld devices remotely. But it also, like poor security and privacy of these systems, it has also enabled adversary to take control of our systems. Recently, we have seen such kind of scary news that adversary could take control of the baby monitoring camera and could talk to babies at home. So to know like what went wrong for these kind of systems, let's take a step back. First, we'll see that inadequate security evaluation early on the development cycles for these systems have failed to identify the missing security and privacy guarantees or under specifications or ambiguity or inconsistencies of the system. So all these lead to design level vulnerabilities. For instance, we have seen that vulnerabilities in the speculative execution like causes the spectra and meltdown type attacks, which are kind of very notorious or famous. I mean, one way around. Also, we have seen vulnerabilities in the design of the Bluetooth protocol. So all these design level vulnerabilities eventually go down to the deployments, that is the real hardware and software implementations. But to make matters worse, these implementations often deviate from the specifications because of kind of operational oversights or oversimplification of complex system interactions. Often, sometimes it is because of poor input sanitizations. So all these lead to implementation level vulnerabilities. For instance, we have seen the famous heartbeat bug in the OpenSSL implementation that actually exploits the buffer overread vulnerabilities. So my research envisioned to address all these problems with the fundamental enhancement in the security and privacy analysis techniques with formal verification, program analysis, software testing, and applied cryptography, and make sure that we integrate these kind of analysis from the ground up, from the kind of starting from the analyzing the technical designs, evaluating implementations, and building high assurance defenses by following the secure by design philosophy, which is kind of more like integrate these kind of analysis techniques from the ground up of a design of a system. So for these, for the past several years, I have worked on 3 different closely related research directions. First of all, I have designed techniques based on formal verification for analyzing the 4G and 5G design specifications. Specifically in the LT inspector work, I have developed model-based testing framework for analyzing the design of 4G LT networks. Also based on static and dynamic analysis techniques, I have developed different mechanisms for verifying whether the implementations deviate from the standard or specifications. Also developed some runtime monitoring techniques to check whether the system at runtime kind of compliant with the specifications. For instance, in the data anomaly work, based on concurrent execution, I have developed an anomaly detection technique that can identify anomalous database transactions issued by a malicious application. Since I'm a kind of a security researcher and my overarching goal is to make the system secure. So based on all these kind of analysis, eventually I built kind of defenses and solutions for cellular IoT and cyber physical systems. For example, in the SimBlue work, based on static analysis, I have developed techniques that can identify the connection state variables automatically and make the connection migration seamless between 2 devices for Bluetooth protocol. So all of my research work is grounded on developing fundamental techniques using formal verification, program analysis, software testing, and applied cryptography. So I guess this is kind of repetition. Yeah, sorry about that. Yeah, so for today's talk, I'll be first discussing an adversarial testing framework for analyzing the design specification of 5G network protocols. Then I will talk about some of the side channel vulnerabilities for 4G and 5G cellular network protocols that we have identified using probabilistic reasoning technique. And finally, I will discuss a new fuzzing technique, which is more effective than the state of the art whenever the binary instrumentation is really hard and there is no kind of code coverage feedback for fuzzing. So let me start with the first one. And as a motivation, we know that cellular networks are nation critical infrastructure. They are widely being used not only for personal communication, but also it enable connectivity for the billions of IoT devices, which essentially enable like many critical services such as smart grid electricity distribution, smart cities, connectivity like connected vehicles or telemedicine. These cellular networks are also used for broadcasting public safety messages in case of emergencies. Like in 2017, if you remember, the news was there, like a ballistic missile alert was sent in Hawaii. Though the message was sent, this kind of emergency alert messages was sent mistakenly at that time, but it created a huge chaos among the people. So adversaries can exploit the vulnerabilities in such system and perform different secure and privacy related attacks, including broadcasting such fake emergency alert messages. So, I mean, it is important that we analyze the design specification of such critical infrastructure and identify the vulnerabilities and fix before the systems get deployed. Like 5G is coming up soon, and that will be deployed at a massive scale. So if we can make sure the design of the 5G networks are kind of secure, then we can make sure these deployments, 5G deployments, will be resilient against many critical attacks. So the problem that we are trying to address here is that how can we systematically verify the design of 4G and 5G network protocols with respect to the promised security and privacy guarantees? So the high-level goal of this problem is to build an automated reasoner that will take the design descriptions of 5G network and the security and privacy guarantees or properties, whatever you want to say, of that system. And after analysis, it will tell that whether the properties are satisfied or not. If the properties are broken or these guarantees are broken, then the reasoner will tell that how the guarantee can be broken. That means it will provide a counterexample by following which the adversary can break the properties and perform an attack. But for analyzing this kind of complex protocol like 5G, which is kind of a beast, I would say, the main challenge is the complexity. This is mainly because of stateful nature of this protocol, and there are also cryptographic constructs such as encryption, message authentication code, or there are certificates. So the techniques that are kind of used for analyzing the stateful networks, they are not might be directly applicable for analyzing the cryptographic constructs and vice versa. Another challenge for analyzing these complex protocols is the presence of multiple participants. Means that 5G networks or 4G networks, any cellular network protocol, we have the device, the phone, we have base station, we have core networks, and in the core network there are multiple such nodes. And the sub procedures for this protocol, like connection establishment, mobility handoff, or kind of call setup, they are intertwined. So this raises the scalability challenge for this kind of analysis. And final challenge is the properties that we want to verify. They are of two properties. One is called qualitative property, and another one is quantitative property. So temporal ordering of events is an example of qualitative properties, whereas rate of receiving or some messages or rate of average number of messages arrival are sort of an example for quantitative properties. So I will actually discuss in detail like what is qualitative and quantitative properties later on. So before going into the details of the analysis, let's first see what are the sensitive information that are stored in a device and what is the cellular network architecture. So by the way, I mean, feel free to stop me at any time if you have any questions. I'd be glad to take that even in the middle of the presentation. So a cellular device in the context of cellular network is called user equipment or UE. So for every device in the cellular network, they have a unique identifier. And that is kind of like hardware. You can think of this, that is a kind of a hardware identifier. And it is called International Mobile Equipment Identity. Now, to get the cellular connectivity, the network operator provides a SIM card. And that SIM card has a master secret key and also an identifier called International Mobile Subscriber Identity, or IMSI. So according to the specification, the master secret key never gets exposed in plain text, but the identifiers IMSI or IMEI, they may get exposed in plain text in certain situations. But if these identifiers are exposed to the adversary can perform kind of more critical attacks, such as man-in-the-middle attack, or intercepting your phone calls, downgrading your service to previous generations like 3G or 2G and can see your conversation. So, I mean, yeah, this is kind of the case if the identifiers are exposed in plain text to the adversary. Now, in the context of cellular network, a geographical area is served by a base station, and multiple such base station consist of a registration area. So the base station works as an intermediary between the device and the core network. And there are many different nodes in this core network. But for today's talk, I'll be focusing on just access and mobility function, or called AMF, which is responsible for managing the connection establishment, mobility, handoff, connection, kind of deregistration, those kind of procedures. And also the core network has a USF or UDM, that is authentication server function, and unified data management. And combining them, we call it home server, which is kind of the counterpart for the previous generations. And this home server stores subscribers' credentials, such as IMSI, the master secret key, or the quality of service information. So for our analysis, the core component is the model checking. So let's first see how model checking works, or what is model checking. So by model, we refer to the abstract behavior of the system. What is the abstract behavior of the system? So let's say you have a kind of protocol or system, you have an event, or you have received a message. So what is the expected behavior? That means that how this system should react with the incoming packet or incoming event. So the system should respond with a particular message. So we call these as kind of abstract behavior, and represent this abstract behavior with kind of graph representation. And for model checking, we need to have some kind of properties like security or privacy properties. So the model checker takes this model and properties as input and checks whether there is any path in the graph where the property gets violated. If there is no such path, then the property gets verified or satisfied. But if there is any such path, the model checker provides that as a counterexample. That means the adversary can follow the steps in that counterexample and perform any kind of security or privacy related attacks. So this is the high level of the model checking. So for our analysis, we have to consider a threat model. And if you are if you want to analyze any kind of system, any protocol, the first thing that should be considered is what is the attacker model or the threat model. So this is kind of the very basic standard for analyzing any protocol, which we call Dolev-Yao style attacker model. So according to the model, this adversary model, we consider the communication channels between the multiple layers inside of a device are secure or private. So they cannot be interfered by the adversary. Also, the communication channels between the base station and the core network, they are also considered secure because they are outside of the scope of like 3GPP or LTE or 5G networks. Because this communication is happening through optical fiber network and they are using IPsec tunneling protocol. So, I mean, for the time being, we consider this is kind of secure. But the communication channel between, between the device and the base station, they are considered public. So that means they can be influenced by the adversarial interactions. So adversary sits in between device and base station, and basically it is considered as an environment variable by our analyzing system. So environment variable means that at every step of the analysis, the system tosses a coin and see whether it is an adversarial turn or not. If it is an adversarial turn, the adversary will non-deterministically chooses an adversarial action. So the adversary can either drop the message or modify or spoof as a legitimate participant and send kind of a spoof message to either parties. But according to this model, like adversary model, it has to adhere to the cryptographic assumptions, which means that if the adversary doesn't know the master secret key, it cannot encrypt or decrypt the messages exchanged between the device and the base station or core network. So for our technique, here's the key insight. So the properties that we want to verify, they have some kind of common characteristics. First one is the temporal ordering of events. So let me give you an example for this. So let's say you are a BUET student or a BUET employee or faculty member. So you want to access kind of a BUET laptop or BUET kind of computer. First, you have to authenticate yourself before you can access any resources. So authentication should come first before any resources are being accessed by you. So this is kind of an example of temporal ordering of events. Secondly is the cryptographic constructs, which refers to secrecy. That is, you want to make your message confidential. Authenticity, that means you want to protect the identity of the sender, tries to kind of prove this is a valid message sent by a valid or legitimate participant. And finally is the property that is common is the linear integer arithmetic, such as the sequence number. Whenever you send a message, you include a sequence number so that you can make sure that the same message should not be accepted twice. These are mainly used for the replay protection for your communication. So the observation is that the general purpose model checker, like symbolic model checker, it is efficient in reasoning about the temporal test properties and linear integer arithmetic properties. Whereas the cryptographic protocol verifier, it is efficient in reasoning about the cryptographic constructs. So the natural question is, how can we leverage kind of reasoning power of these two different verifiers? How can we get the best of these two? So leveraging this intuition, we built our adversarial testing framework, and we have instantiated that framework for the 5G network protocol and call it 5G Reasoner. Note that this kind of adversarial testing framework is kind of general. It can be applicable for any network protocol or any system that have kind of client-server architectures. So from the technical specification of 5G network protocol, we manually construct the finite state machines or the model of the device, base station, and the core network. And combining them, we call abstract cellular model. And note that in this abstract model, we replace all the cryptographic messages, cryptography related messages with their plain text counterparts. This is mainly easy of reasoning. Now, to efficiently reason about the adversarial interaction, we incorporate adversarial threats into this benign protocol model and get the threat instrument net model, which we feed into the model checker. Now, the model checker, if you remember that model checker requires the model or the finite state machine of the system and the properties, but 5G doesn't provide any explicit list of properties. For addressing this problem, we resort to conformance test suites or technical requirement documents provided by the 5G. So conformance test suites basically list of unit test cases, and most of the unit test cases are for functional correctness, but some of them are for security and privacy related test cases. So we identify those and translate those unit test cases to the properties. Also, we collect implicit properties from the both kind of technical specifications and technical requirements documents. And once we have the list of desired properties, we feed that to the model checker. Now, model checker takes each of these properties and checks whether the properties are valid or not, or verified or not. If the properties are satisfied, I mean, we are good. But if the properties are not satisfied, the model checker provides a counterexample. Note that this counterexample could be spurious because of the abstraction we have used in the first place, that replacing all the cryptographic related messages with their plain text counterparts. To filter out this spurious counterexample, we don't know whether it is spurious or not. We model this scenario of the counterexample for the cryptographic protocol verifier. So we generate a model and also the corresponding queries, that is the secrecy or privacy queries, and provide that to the cryptographic protocol verifier. So cryptographic protocol verifier tries to adjudicate whether each of the steps in the counterexample are valid or not. If each of all the steps in that counterexample are valid, we consider that as a valid attack. I mean, that should be realized in the real life. Otherwise, from the output of the cryptographic protocol verifier, we kind of find an invariant so that, and we add that invariant in the model so that the same spurious counterexample will not appear in the next iteration. So this is how we go on until we get an attack or there is no attack after refinement. And this is kind of a philosophy taken from counterexample guided abstraction refinement, which is famous, kind of a famous technique in formal verification. So the philosophy is kind of same to SIGAR, counterexample guided abstraction refinement. So we kind of evaluated our techniques for both 5G and 4G network protocols, and the techniques that we have developed for 4G LTE called LT Inspector. We could identify 11 new attacks and 10 new attacks for 4G LTE and 11 new attacks for 5G networks. I'm not going to the details of each of the attacks, but I'm just trying to summarize what are the implications for these attacks. Authentication bypass, the adversary can actually, doing these, can spoof the location. Like, let's say I'm currently at Penn State, I can spoof the location and claim that I am from California. And also we have shown that authentication bypass can also be done with this attack. Also location tracking, like adversary can track a location, some kind of temporary identifier exposure, which causes also the location tracking, overbilling your like overcharging to your bills, phone bills or SMS, many kind of denial of service attacks, service profiling, which means that the adversary can track whether you're currently making a phone call or sending SMS, or whenever you are kind of using any cellular service, what are the pattern, some kind of denial of service attacks causing the battery depletion, and some kind of artificial chaos, which I'm going to show for which I'm going to show a demo just now. So let's assume that you're watching a kind of football game in a large stadium, I'm sure, or any kind of cricket match in Bangladesh, and the adversary is trying to send a spoofed message. So we exploit a lack of authentication for one of the messages in cellular network, and using this USRP, the adversary actually set up a fake base station and sends this spoofed message. Kind of this is an emergency alert messages. It says that there is an active shooter in place, take shelter or stay safe. So if that is the case, I mean, if the adversary can successfully send this kind of emergency messages, it could be like earthquake, like emergency earthquake or tsunami alert messages, or it could be Amber Alert. Like it may create a huge chaos, like in a crowd, like stadium, like people watching the cricket match or football game. So, I mean, it may cause like physical, damage because of stampede, because people will get panic and kind of start running like arbitrarily. So this is kind of a problem that we have identified, and we have showed a demo. This is kind of scary. So we have reported all these findings, like problems, to the cellular standard body. In short, it is called GSMA. And they have acknowledged our findings, and they have listed our names on their website in the Security Hall of Fame. And based on our findings, a number of changes will be appearing in release 16, which is the latest release for the cellular specifications. Also, we have helped a major US network operator to fix one of the problems there, like use of null encryption for their control plane messages. And interestingly, whenever I was in Bangladesh, I tested all of the network operators in Bangladesh, and they have the same issue, like same vulnerabilities. They use null encryption in their control plane messages. And if that is the case, the adversary can actually eavesdrop your SMS, eavesdrop your conversation, and they can see whatever you're sending. So, I mean, I didn't have a chance to report that because I don't know where to report, but this is what I have found for all the network operators in Bangladesh, including GP, Robi, yeah. Also, we have made our tool open source. So Intel has used this tool internally, and they have also identified a couple of vulnerabilities. Imtiaz is here. Imtiaz did his internship twice at Intel. He actually he has shown that how our tool can be useful for analyzing their systems, their implementations. And he has also got some interesting results. Probably Imtiaz can also tell about it later, in the future. So also this work has been covered by many media outlets worldwide, including Forbes, MIT Technology Review, Wired, like New York Times, and so on. So as a quick recap, I have just discussed the adversarial testing framework for analyzing any design specification of any network protocols, and I have shown that how we can instantiate that framework for analyzing the 5G design specifications. So next, I'm going to talk about some of the side channel vulnerabilities that we have identified using probabilistic reasoning techniques, and those side channel vulnerabilities are for 4G and 5G cellular network protocols. So before moving into my next topic, I would like to see if you have any questions from the audience. All right, seems like we have no questions. I can see Ifti Bhai. Ifti Bhai. Hello, Ifti Bhai.
Hello, Rafiul.
কেমন আছেন ভাই?
এই তো ভালো, কেমন আছো?
এই তো ভাই। Good to see you ভাই।
Thank you. একদম টেলিকমের অনেক কোর কাজ, ঠিক আছে? মজা লাগছে।
Okay. So ভাই আপনার সাথে পরে কথা বলবো. Let's first finish the talk, then we can discuss. Yep. So, as of now, we have seen that 5G reasoner is efficient about reasoning the temporal trace properties, kind of a single trace. If you remember that we had a counterexample, like a single counterexample. But what about multiple, like more than one traces, reasoning about more than one traces? And these kind of reasoning about more than one traces at the same time, we can actually reason about the side channel properties. So to efficiently reason about these kind of side channel properties or quantitative properties, we take a deep dive into a particular kind of sub-protocol of cellular system and see whether we can devise or develop any probabilistic reasoning technique to efficiently reason about side channel vulnerabilities. For these kind of analysis, we first take into account the paging procedure. Paging is an important procedure for cellular network, which is responsible for kind of managing the mobility. Also kind of it is responsible for handling the incoming messages or incoming phone calls. Also, it is used for broadcasting emergency alert messages that we have just seen the demo. So let me first give you a high-level details, like how it works, how this paging procedure works. So after the mutual authentication between your device and the core network, if you have any kind of cellular activity like phone call or SMS, the device will remain connected to the network. But after a while, if the device doesn't have any kind of cellular activity, right now you're kind of, probably if you are kind of listening to my talk, if you're not using your phone might be in the idle state. So it is because of the device tries to kind of optimize its power, its battery. So it goes to the idle state. And during this idle state, if there is any incoming phone calls or messages, then how the core network will notify the device that your device is kind of idle state, more in the kind of a sleeping state, but how the device will receive these incoming messages. The core network, whenever it finds any incoming service for your device, it sends a paging request message to the base station to which your device was last seen connected. Now the base station will broadcast the paging message to all its cellular subscribers, nearby subscribers. And note that this paging message doesn't have any kind of encryption or doesn't have any kind of authentication. This is a kind of a broadcast message. So receiving the message, the device, to receive that message, device in the sleeping state, it periodically wakes up. And if it finds that there is any such kind of incoming service notification message encoded in the paging message, the device will wake up and connects back to the base station and core network, and then receives that service. So the key takeaway here is that if I know your phone number, I can make a phone call to your device, and your device will receive a paging message from the base station to which your device was last connected. Now, in the idle state, the device periodically wakes up, as you have seen, that to receive the paging message, which is kind of an indication of service, incoming service. So the time at which device wakes up, we call it paging occasion or paging frame index. And note that these, to receive the paging message, kind of in a perfect time, the device and the base station, they need to be time synchronized. Now, without loss of generality, let's assume that the time domain for 4G and 5G networks, they are divided into 128 system frames, where each frame is a length of 10 milliseconds. Now, the question is, which device will wake up at what system frames? So it is decided based on the last 7 bits of the device's IMSI. So that means, in this case, the last 7 bits is the 11 for the last 7 bits of the device's IMSI. The device will wake up at 11th system frames in the time domain. If 2 devices have the same last 7 bits of their IMSIs, then they will share the paging occasion or paging frame index. So apparently, it's kind of a perfect design, right? In terms of optimization and performance. But what can go wrong here? The problem is the paging occasion is fixed. Why? Paging occasion is decided based on the device's IMSI. And as long as you're using the same SIM card, your IMSI is not going to be changed. And your paging occasion will not going to change. That means your paging occasion is fixed for the entire life cycle of your SIM card. If that is the case, like fixed paging occasion, we question that whether the adversary, only knowing victim's phone number or any social network identity, such as Facebook identity or Twitter handle, can identify victim's paging occasion or paging frame index. Also, if it is possible, whether the adversary can identify or track victim's presence in a particular target area, only by knowing your phone number. For this, the first attack that we have identified is the tracking via paging message distribution, or in short, we call TORPEDO. So without making any kind of adversarial actions, the adversary first passively eavesdrop all the paging message arrival in 128 system frames that we have just seen. So this is a kind of a real trace I have collected at West Lafayette, Indiana. And it shows that number of paging message arrivals in 128 different system frames. So this is what we call also base paging rate. Now, knowing the victim's phone number or kind of Twitter handle, the adversary can make a number of phone calls or send a number of tweets or SMS. So for each of these phone call or SMS, the base station will send a paging message to the device or to the victim. So the adversary will continue making phone calls until it finds this kind of skewed distribution. So from this distribution, we can see that there is a particular paging occasion or paging frame index where there is a significantly higher number of paging message arrivals than the rest of the others. So basically, it says that this is the paging occasion or paging frame index for the victim because of so many phone calls I have targeted for the victim. And it essentially leaks the location. That is, it signifies that the victim was present in that particular target area. And since the adversary can identify paging occasion, which is the last 7 bits of the victim's IMSI, it can partially expose victim's IMSI. Now the question is, how many phone calls or SMS or any tweets are required for the adversary to correctly identify whether the victim is present. For this, we have designed 3 analysis techniques, but I'm going to present just the last one, which is more efficient. We call likelihood-based analysis. And for this kind of analysis, we take into account a number of side channel information. First one is the number of paging records in a single paging message. And these paging records indicates whether the incoming service is through packet switch network, like through VLT or LT network, or whether it is a circuit switch service. That means the device has to fall back to the previous generations and take the service, and then again it will come back to 4G LTE. We also take into account timing information. That means after making a phone call, what is the probability of receiving a paging message between time interval T2 and T3, which is kind of from the graph, we can see that it is significantly higher than that of the probability at time T4 and T5. We also take into account the base paging rate for the packet switch and circuit switch records. So all these side channel information, taking into account, the adversary first computes the likelihood Li, that is the ith frame among the 128 system frames, is the victim's paging frame index or paging occasion. We also compute L-, that is in case the victim is not present in the particular target area. And finally, the adversary identifies the ith frame is the victim's paging frame index whenever likelihood of I is significantly higher, an order of magnitude higher than that of the other system frames. So we have evaluated our analysis for different network conditions for different network services, but I'm not going into the details of these results. The key takeaway is that the adversary requires 4 to 10 phone calls or SMS or tweets to identify victim's paging frame index. Now the question is that if the adversary makes phone calls, whether the victim can identify whether he or she has these incoming phone calls. But interestingly, we have identified that we can make ghost phone calls, which means that the adversary can start the phone call. It makes sure that the paging message has been sent to the device, but before making any setup of the phone call, after your paging message, there will be a SIP session established. But before establishing any SIP session, the adversary hang ups the call. So this is called the ghost call. So the victim will not be aware that whether there's any incoming phone call for him, if that is the ghost call. And that is how we kind of secretly, the adversary can make phone calls secretly. So, the victim is not aware of any such attacks. So we have reported this problem to the Cellular standard body, and in 2019, I guess, and they quickly sent out a fix, which says that instead of having fixed paging occasion, we should have variable paging occasion based on a temporary identifier called TMSI instead of the fixed identifier or unique identifier IMSI. So this is a classic example, actually, without having rigorous security evaluation of the proposed fix, they have quickly sent out the standard body or Cellular standard body. And it didn't take us too long, actually, to show that the proposed fix is kind of broken, exploiting other vulnerabilities along with this one. And we have shown that still the adversary can identify victims' paging occasion with some kind of other techniques. As I mentioned, that this is a classic example that without having any proper security evaluation or kind of formal verification of the proposed fix, they quickly sent out and it was shown to be broken. So as I mentioned, that we have kind of reported all these vulnerabilities to GSMA. They have proposed a fix. Also, we have shown that proposed fix are broken. We have also come up with a different solution, and that was actually published in PETS 2020. I'm not going into the details. Again, also this work has been widely covered by many media outlets. So based on these torpedo attacks, we have shown that some of the bits of the IMSI can be exposed to the adversary, but exploiting this torpedo and exploiting other vulnerabilities in the 4G and 5G, we have devised 2 other attacks called IMZ cracking, which can completely retrieve the whole IMSI, all the bits of the IMSI. For that, the adversary requires some kind of active attacker. That means they have to set up some kind of fake base station. For the torpedo, we don't need any fake base station or active attacker. The adversary just passively observes the network. So for those kind of active networks, fake base station is a real problem. So what we have seen that after the root cause analysis, we have seen that the initial broadcast messages by the legitimate base station, these are the system information block, master information block, and frame synchronization signals. They are sent in plain text, and they don't have any kind of authentication. So exploiting this vulnerability, the adversary can set up a fake base station that impersonates those legitimate ones and broadcast signal with higher strength. So as a result, the device is always kind of power hungry. I mean, they always look for the base station that can serve better signal strength. So exploiting this, the adversary can successfully force the device to detach from the legitimate base station and force the device to connect to the fake one. Now the fake one can actually inject many different messages and compromise the devices. So natural solution for this kind of problem is the incorporate the authentication for these broadcast messages, initial broadcast messages. But incorporating the authentication for broadcast messages is a real challenge. And unfortunately, until now, neither the standard body, the cellular standard body, nor the network operators, they have come up with kind of any practical solution for broadcast authentication. But recently, the 3GPP, which is third generation partnership project, which is also the another name for the cellular standard body, they have considered symmetric key authentication scheme for this kind of broadcast authentication. And they are trying to use Tesla, which is a well-known broadcast authentication for cellular, like sensor networks. They're trying to see whether they can use the similar technique for cellular networks. But unfortunately, the assumption for Tesla is that they require a pre-existing authenticated channel between the device and the base station. But the problem, this is the problem we are trying to address. We don't have any authenticated channel between the device and the base station, and that's what we are trying to establish. But if that is the assumption for the Tesla is not going to work in the context of cellular network. To address this challenge, we have proposed our own PKI-based mechanism. I'm going into that solution in a very high level. So the home server, that is the part of the core network that will have the root certificate, and that certificate will be self-signed, and the same certificate will be stored at the device side. And AMF, which is the kind of mobility anchor point, as I mentioned, manages the connection establishment, those kind of things. It will have the certificate signed by the home network, and base station will in turn get this certificate from the AMF, signed by the AMF. And now when the base station will broadcast these master information block or system information block messages, it will include the message, also the signature signed by the respective parties, and also include all the certificate chains. And whenever the device will receive that message, it will verify the authenticity of the signature, also the certificate chain. So it's kind of very trivial solution. It may appear, but in practice, actually, it's not. Because to make these kind of PKI-based solution kind of applicable for cellular context, there are many different technical challenges. First, the certificate chain length. I mean, if you include too many bytes in the kind of radio packets, these are licensed spectrum. And for each of the bytes in the packet, the cellular network operator has to spend money. So each of the extra bytes costs them. So we have to be very careful about including a long length of certificate chain. Secondly, the certificate revocation. That means once the base station, if it is compromised eventually, we have to somehow incorporate this knowledge to the device that we should not trust that base station anymore. Finally is the signature generation overhead. If it takes too long to generate the signature of the message, it may affect the strict scheduling policies of these broadcast messages, because these broadcast messages are sent every 40 or 80 milliseconds periodically. So if the signature generation takes more than 40 milliseconds, we are kind of affected by this critical challenge. So to address all this problem, we proposed optimized PKI scheme in which we actually employ a number of optimization at different levels. First, at the PKI level, we kind of design lightweight PKI mechanism, like certificate encoding mechanism. Instead of using traditional X509 based certificate, we just incorporate kind of all the relevant and necessary information in that customized encoding of certificates. At the protocol level, we try to minimize the transmission of certificate chain by aggregating the authentication of multiple messages. And finally, we try to reduce the size of the signature by aggregating multiple signatures through offline-online signature-based generation scheme using BGLS and SCRA. I'm not going into the details of this protocol, just giving you some kind of high-level idea that at where we have employed these optimizations. And so this was the kind of the first work along that direction. We are kind of lucky that we could discuss this technique with Federal Communication Council, FCC in USA. They really like this approach, and they want to see whether this defense can be employed to prevent this kind of notorious fake base station problem, or sometimes we call IMZ catchers. These are a real problem, in many different countries, and this may solve this problem, our solution. Also, this has been covered by some media outlets at USA. So as a quick recap, I have just discussed kind of how we can design adversarial testing framework for analyzing the 5G design specification. I have also talked about side channel vulnerabilities, and I have also discussed kind of a defense for preventing the active attackers, mainly for prevention of fake base station problems in cellular networks. Finally, I'm going to talk about some kind of vulnerabilities in the implementation. Like so far I have discussed just vulnerabilities in the design specification, how we can address them, how we can make sure that these vulnerabilities in the design level will not appear whenever they get deployed. But how about the systems that are already deployed? What are their kind of correctness and robustness in terms of implementations? So even if we make sure that the communication between the device, like your smartphone and base station are secure, we have another processor in our phone that we call application processor, and that runs all the general purpose application, like your phone call app or SMS app or your Viber or Facebook app running on your device. These are general purpose applications. And if you need, let's say, if you need to make a phone call, the app will send a command to the application processor. Then the application processor will send an AT command to the baseband processor to make the phone call happen, like this. So so that means the application processor communicates with the baseband processor, the cellular modem, with the one of the interfaces called AT interface. Now, interestingly, we have seen that when your smartphone is connected through USB or Bluetooth interface, they accept AT commands. So what can go wrong here? So let's say your phone is connected, you are charging your phone through USB charging station, and those charging stations may not be untrusted. I mean, they are publicly available, like available at the airport or bus station. So the adversary can send any kind of AT command to make phone calls, any secret phone calls, like which is not visible to the victim, or can send SMS or can read your text or SMS. Similarly, for the Bluetooth, which is inherently vulnerable for the man-in-the-middle attack, even if your phone is connected to your trusted kind of Bluetooth controller, that might be under control of man-in-the-middle attacker, and adversary can send invalid or valid AT commands. Even the adversary sends like kind of invalid or valid AT commands. A recent paper has shown that sending valid AT commands, this kind of phone calls, secret phone calls, or private information exposure can happen. but those were kind of valid AT commands. But what the problem could be there is that there could be incorrectness in the AT command execution process, or incorrectness in the AT parser that parses the AT command and further processes down the line in the baseband processor. So we try to argue that whether there is any misuse or abuse of invalid, that means syntactically invalid or semantically invalid AT commands over USB and Bluetooth interface. So for this kind of systematic analysis, we try to address this problem, that it is possible to systematically analyze the correctness and robustness of the AT command execution process, and those AT commands could be like baseband related AT commands, that is related to cellular modem. So for this kind of analysis, there are two possibilities. One is the static analysis and dynamic analysis, but problem is that the firmwares for the baseband they are rarely available. Even if they are available, they are sometimes very vendor specific. They are processing kind of different packing and unpacking strategies, different obfuscation strategies, which makes the static analysis really challenging. The other option is the dynamic analysis. One of the famous techniques is called fuzzing. I am sure many of you are aware of fuzzing technique. The high level idea is that it starts with an initial input, random input, which we call seed, and it mutates the input in the process to generate some kind of invalid or different kind of inputs, and checks whether the mutated inputs, how it behaves when it is given to the system under test. And while doing this, the fuzzing tries to find the code coverage information. But to find the code coverage information, we need to instrument the code. But if the firmwares are rarely available or there are obfuscation, the binary instrumentation to collect the code coverage information is really challenging. But even if we assume that the code coverage information is there, then based on the code coverage information, the fuzzer tries to generate more meaningful inputs to find the crashes or incorrectness. So this is how actually fuzzing works. But as I mentioned, that code coverage information is really hard to obtain whenever the firmwares are unavailable or there are obfuscation or different packing strategies are there. To address this problem, we have developed ATFuzzer, which is a grammar-guided evolutionary fuzzing framework. The high-level idea is that we first construct the context-free grammar for the AT commands. We actually manually construct this context-free grammar and provide that to the evaluation module. So the evaluation module, they systematically changes the AT grammar with mutation and crossover techniques. The intuition of using AT grammars for mutation and crossover instead of using concrete instances of AT command is that to generate diverse set of invalid AT grammars. So each invalid AT grammar represents a classes of invalid AT command instances, the concrete AT command instances. So this actually helps us to effectively search the input space and to generate, to test the system both syntactically and semantically with diverse set of inputs. Now, once we have these invalid AT grammars generated by mutation and crossover, we provide that to the evaluation module. For each of the invalid AT grammar, we generate concrete instance of the AT command. AT grammar. That means we get the actual input, the concrete input, and send that to the device under test, and check the responses from the devices. It may provide execute the input and provide you the OK or error messages. So we compute the precise time of this execution. Since we don't have any code coverage information because of unavailability of the firmwares or obfuscation, we kind of consider this execution time as a loose indicator for the code coverage. That means higher the execution time, higher number of basic blocks or instructions have been executed. So we consider these as a feedback, also consider the output of the device. That means after execution of the particular input, the device may get out of service, can go to this kind of unsafe state. All these outputs and unsafe states are kind of considered as evaluating the score for each AT grammar. So based on this score, we kind of select the highest scored grammar for the next iteration as the parent for the next iteration. And using the mutation and crossover, we generate the population for the next phase. And that's how it goes to the both evaluation module, and evaluation module. And fuzzing goes on until some time we stop. So the interesting thing is that at the end of this fuzzing, we could uncover classes of incorrect inputs, not a single incorrect input. And each class represents a kind of a set of incorrect AT command instances, which are incorrect. So, I mean, this is hugely impactful because rather than just a single input, we can identify class of inputs and that have the similar misbehavior impact. So this is kind of very interesting and was appreciated by the research community. So we have evaluated this analysis with 10 devices of with the different Android versions of operating systems, starting from 4.3 to 8.0. For the Bluetooth, we could identify 4 invalid AT grammars, and for USB, we could identify 11 invalid AT grammars. So let me show you one of the demo for one of the attacks we have identified. So let's say your phone is not connected to any USB or Bluetooth peripheral. Your phone is kind of more secure. But as soon as your phone is connected, let's say your CarPlay of your car to your Bluetooth interface, I mean, your headphone is connected to the CarPlay, that might be problematic. So the adversary, as I mentioned, that the Bluetooth protocol is inherently vulnerable for the man-in-the-middle attack. Even you trust your CarPlay, that connection might not be secure, and adversary can inject invalid AT commands. So let me show you one of the examples of invalid AT commands. Your phone is connected to 4G LTE in this demo, and sorry. Yeah. So let's say your phone is connected to 4G LTE, and the attacker's objective is to expose some kind of sensitive information. The adversary is trying to send these invalid command from the terminal of the Bluetooth terminal, and sends this AT plus CIMI, ABCD. This is an invalid command, syntactically incorrect command according to the AT command specification. And sending this command, device response with is IMSI, which is kind of unique and sensitive information. As I mentioned, that once IMSI is exposed, the adversary can intercept your phone calls or SMS. So this is really problematic in terms of security and privacy. Yeah. So we have reported the vulnerabilities to the affected vendors, Samsung and Google. They immediately patched these kind of problem. They have also blocked USB and Bluetooth interface. That means if you connect your phone to any public charging station, the phone will not accept anymore the AT commands through USB or Bluetooth. Also, they have reported this vulnerability in the form of CV, or coordinated vulnerability exposure report. Also, we are trying to collaborate with some kind of industry folks here, Rockwell Collins, who are interested in fuzzing their cyber physical systems. And also this work has been covered by some kind of media outlets. Yeah. So I have already discussed all of my talk agendas today. So I'd like to keep this kind of floor open for the future work. I'm in collaboration with with BUET students and faculty members. I'm going to talk about some of the high level kind of goals of the future work, sort of what we can do. And probably you can students and faculty members present here can chime in and discuss more what we can do in collaboration. So in lining with my previous work, I'd like to continue working on designing techniques that will be used from the ground up analysis, starting from designing the specification, analyzing the specification. And once we have the implementations, we should make sure that whether the implementations are compliant with the specifications, and based on all these kind of analyses, building defenses and countermeasures. And as I mentioned, that most of my work are grounded on developing fundamental techniques using formal verification, program analysis, software testing, cryptography, and also, I mean, machine learning is kind of another tool or natural language processing which we can use in my future work. And as I said, that there are huge opportunities. We have just on the surface level at 5G or 4G specification or implementation. There are many more opportunities for the different aspects of 5G protocols. For example, software-defined networking, that is kind of a huge component for 5G networks. We have just analyzed the design specifications, but we didn't explore much about what about the implementations, what are the security and privacy properties that are guaranteed in the implementations. Definitely that is kind of one of the future goals for me. In lining with that, also IoT system, like analyzing the IoT systems, make sure that whenever you install different kind of trigger action rules or applications, you make sure you don't mess up with your system. Don't make your system into unsafe state, because let's say you have installed different apps, like whenever you come into your home, your lights will turn on, your fan will be turned on, and your curtains, smart curtains, will be dropped off. I mean, your refrigerator kind of will be turned on into more like active power state. And if we have so many rules kind of installed in the IoT space, like in your smart home or your smart office, there could be some kind of conflicting rules, or kind of all the rules may have kind of unseen consequences, which we are not expecting. Also, Internet of Things is really challenging because of heterogeneity, because we are using different devices from different vendors. They have different kind of technologies, communication technologies like Bluetooth, Wi-Fi, or Zigbee, different cloud settings, like device can talk either through gateway or either through cloud. So, I mean, this is really kind of a mess, I would say. I mean, it's really hard to make sure this is kind of a secure because of heterogeneity and lack of secure by design or any standardized solution for it. Similarly, the cyber physical systems, it is like similar to Internet of Things. Now it is powered by IP network protocol. All the devices are connected, like connected vehicles or kind of smart grid electricity distribution, which are using these 4G, 5G network protocols. And whenever we are trying to make sure security is there, there is an issue of performance. So we have to make a right balance between the security and performance. So there are many challenges actually we can address. I mean, I am left with so many feature works that we can do based on these kind of techniques that I actually use as my kind of armory. So with that, I'd like to summarize that in this talk, I have shown that how my research leverages formal verification, software testing, program analysis, and applied cryptography to systematically analyze the design and deployments, and how we can use that also for building high assurance solutions. And the challenge is that how can we make our existing techniques, analysis techniques, scalable, and how we can actually make sure that we can have a uniform verification for the next generation cellular, IoT, or cyber physical systems. So with that, I'd like to thank you all for your kind attention, and I'd be happy to take any questions.
Thank you, Rafiul. কারো কোনো কোয়েশ্চেন? আমার একটা কোয়েশ্চেন ছিল অবশ্য, আমি জানি না এটি কমান্ড নিয়ে অবশ্য আমার কাজ করার এক্সপেরিয়েন্স আছে। এটি কমান্ড দিয়ে এসএমএস, মানে ওই যে এটি কমান্ড তো তোমার একদম বেসিক লেভেলে, মানে যখন স্মার্টফোনও ছিল না ওই সময়ও, যেমন আমার এক্সপেরিয়েন্স আছে নোকিয়ার ওই ফোনগুলায় এফ বাস নামে একটা প্রোটোকল আছে, এফ বাস দিয়ে নোকিয়ায়, তো ওখান দিয়েও এটি কমান্ড কাজ করতো। আর আমার অবশ্য কোয়েশ্চেনটা হলো, ট্রু কলার নামে একটা অ্যাপ আছে, ইউজ করছো বা দেখছো তো? ট্রু কলার নামে একটা অ্যাপ আছে যেটা অ্যান্ড্রয়েড ফোনে যেটা করে ওটা কাইন্ড অফ একটা, মানে ট্রু কলারের কাজ হলো ধরো মানে ইজিলি যদি বলি, ধরো তোমার ফোনের কন্টাক্ট লিস্টে যারা আছে, তো তুমি যদি ট্রুকলার অ্যাপ ইনস্টল করো, তো ওদের যে পাবলিক ডেটাবেস, সেই ডেটাবেসে ইনফরমেশন গুলো স্টোর করে। সো এরপরে
আচ্ছা।
দেখা যায় যে ওই নাম্বার থেকে যদি আমার যদি ট্রুকলার থাকে, তোমার কন্টাক্ট লিস্টে একজন আছে যে ফোন দিছে, তোমার কন্টাক্ট লিস্টে সে যেই নামে সেভ করা আছে আমাকে সে সেটা দেখায় দেয়। ঠিক আছে, এটা এটা
আচ্ছা।
বাংলাদেশে খুবই ভালো কাজে লাগে। ধরো কোন
আচ্ছা।
উবার ড্রাইভারটা ভালো না, সেটা
হ্যাঁ, হ্যাঁ।
ট্রুকলারের মাধ্যমে খুব ভালো বোঝা যায়, বিকজ কেউ না কেউ তাকে খুব বাজে নামে সেভ করে রাখছে। তো
আচ্ছা।
ট্রুকলারের একটা রিসেন্ট ফিচার আমি দেখলাম। ট্রুকলার এরকম হয় যে ধরো একটা কল আসছে, যেটা তুমি বললা ওই যে ফেসের কথা, পেজিং এর যে কথাটা বললা, বেশ কয়েকবার এরকম হয় ট্রুকলারে যখন একটা কল আসে, ঠিক আছে, আমার কাছে ফোনটায় তখন কলটা বাজে নাই, বাট ট্রুকলার নোটিফিকেশন দিচ্ছে যে ইনকামিং কল ফ্রম অমুক।
আচ্ছা।
ঠিক আছে, এবং মাঝে মাঝে এরকম হয়েছে আমার সাথে যে অ্যাকচুয়ালি কলটা কিন্তু আসে নাই। ট্রুকলার মানে ধরো কেউ ফোন করতে নিছে, বাট লাস্ট মোমেন্টে কাইটা দিছে, ধরো যে না থাক, ফোনটা করলাম না। তো ট্রুকলার এটা ডিটেক্ট করে ফেলে। তো একটা অ্যাপের পক্ষে এটা কিভাবে সম্ভব, মানে কিভাবে এটা, মানে তোমার কোনো আইডিয়া আছে কিনা যে?
রাইট, আই মিন এটা হইতে পারে ভাই যে আসলে মানে একটু স্লাইট ডিফারেন্স আছে, যেটা আমরা ঘোস্ট কল বলতেছি। আসলে ট্রু কলার আপনার এমন হতে পারে যে ও তো একটা ভয়েস ওভার আইপি স্ট্যাবলিশ করার চেষ্টা করতেছে, বাট পুরোপুরি হয়তো ভয়েস ওভার আইপি সেশনটা স্ট্যাবলিশ হয় নাই। সো সাম কাইন্ড অফ মানে বিফোর you see any ring call,
হ্যাঁ,
any kind of
ওকে, হ্যাঁ, মানে আমি বুঝতে পারি
ওটা হ্যাং আপ হয়ে গেছে,
হ্যাঁ।
সেন্ডার হচ্ছে কলার হ্যাং আপ করে দিছে, বাট মানে সিপ সেশনটা ভয়েস ওভার আইপি সেশনটা ইনিশিয়েট হয়েছে বাট কমপ্লিট করতে পারে নাই। তো বিফোর দ্যাট ও আসলে কোনো ইন্ডিকেশন পাইতেছে, দ্যাটস ওয়াই মানে ও হচ্ছে এরকম কোনো একটা নোটিফিকেশন দিচ্ছে, বাট আসলে আপনি কোনো ফোন রিং শুনতে পারেন নাই, এরকম হইতে পারে আসলে।
আসে নাই, ফোনটাই আসে নাই, বাট আমি নোটিফিকেশন পাইছি যে, আমার কাছে বেশ ইন্টারেস্টিং লাগছে, বিকজ কন্টাক্টের ইনফরমেশন।
আপনি নোটিফিকেশনটা কি ট্রুকলার অ্যাপ থেকে পাচ্ছেন নাকি
ট্রুকলার অ্যাপ,
নরমালি?
ট্রুকলার অ্যাপ থেকে।
আচ্ছা, হইতে পারে ওইটাই আর কি, আমি আসলে শিওর না,
মানে
যেহেতু
আমার কাছে ধরো
আসলে দেখি নাই।
ট্রুকলার যে কন্টাক্ট ইনফরমেশন আমাকে দিচ্ছে, ওটা ফাইন, ও ডেটাবেসে সার্চ করে, কিন্তু যেই ফোনটা আমার কাছে আসতেছে সেটা সে বলে দিচ্ছে, যেটা অ্যাকচুয়ালি আমার কাছে আসছে সেটাও ফাইন, বাট যেই কলটা আমার কাছে আসে নাই, মানে আমি অ্যাকচুয়ালি কোনো রিংটোন শুনি নাই, কিচ্ছু হয় নাই, সেই কলটাকেও সে আইডেন্টিফাই করে অ্যাপ থেকে আমাকে নোটিফিকেশন দিচ্ছে যে অমুক কল করতেছে। বেশ কয়েকবার হয়েছে আর কি, ইন্টারেস্টিং। মানে এটা আসলে তোমার ইয়ার জন্য বেশ ইন্টারেস্টিং হইতে পারে। ট্রুকলার অ্যাপ তোমার রিসার্চের জন্য একটা ভালো টেস্ট বেড হইতে পারে।
হ্যাঁ, শিওর, আমি আমরা আসলে দেখতে পারি আসলে অ্যাপটা অ্যানালাইসিস করে যে কি হইতেছে আসলে।
অনেকে এটা ইউজ
বাট
করে,
এটা আসলে
অনেকে এটা ইউজ
প্রাইভেসি,
করে না।
আপনি যদি দেখতে পারেন ড্রাইভারের নাম বা ডেটাবেসে কি আছে, সেন্ট্রাল ডেটাবেসে কি আছে, কাইন্ড অফ এ প্রাইভেসি কনসার্ন, রাইট?
হ্যাঁ, না এই অ্যাপটার এই কনসার্নটা আছে, অনেকে এই জন্য এটা ইউজ করে না, বাট মানে দেখতে পারো স্টাডি করে।
হ্যাঁ, শিওর, মানে অফ কোর্স দিস ইজ এ গুড সাজেশন ভাই। যদি অ্যাপল স্টোরে বা গুগল স্টোরে যদি থাকে তাহলে ডাউনলোড করে দেখতে পারি।
অ্যাপ স্টোরেও আছে, অ্যাপল স্টোরেও আছে, বাট সমস্যা হলো মেবি তোমার আইফোনের অ্যাপ হিসাবে খুব একটা বেশি পারমিশন পায় না, কিন্তু অ্যান্ড্রয়েডের অ্যাপ হিসাবে সে অনেক পারমিশন নিয়ে কাজ করতে পারে।
আচ্ছা, আচ্ছা,
আচ্ছা, কারো কোনো কোশ্চেন থাকলে আইদার হ্যান্ড রেজ করো বা চ্যাটেও লিখতে পারো। এটা কিন্তু
আমি একটা প্রশ্ন করতে চাই রাফিউলকে। রাফিউল, এই সিকিউরিটি ফ্ল গুলা যে দেখা যাচ্ছে এখন আমাদের দেশের হ্যান্ডসেট গুলো তো স্টিল এখনো 3G, এবং মেইনলি এই প্রোটোকলে যে আপডেট গুলা মানে তুমি যেগুলো সাজেস্ট করছো, মানে যেগুলো লোকজন অ্যাডপ্ট করছে, সেগুলো তো বেসিক্যালি ইকুইপমেন্ট ভেন্ডররা ইনফ্যাক্ট তাদের এন্ডে ইনকর্পোরেট করছে, কিন্তু হ্যান্ডসেট গুলো যদি আপডেট না হয় তাহলে কি আমরা এইটার বেনিফিট পাবো?
ভেরি গুড কোয়েশ্চেন ভাই। হ্যাঁ, মানে জিনিসটা হচ্ছে যে আমরা যেগুলো রিপোর্টিং করছি, মোস্ট অফ দি ইস্যুস আপনার হচ্ছে 4G এবং 5G রিলেটেড। ফার্স্ট অফ অল এটা ভেটিং হবে আপনার হচ্ছে স্ট্যান্ডার্ড বডি দ্বারা, যেখানে হচ্ছে মানে প্রতিটা নেটওয়ার্ক অপারেটর 3GPP-র সাথে এভরি নেটওয়ার্ক অপারেটরস ইন দি ওয়ার্ল্ড দে আর কাইন্ড অফ কানেক্টেড। তো যখন তারা বলবে যে চেঞ্জ করবে স্ট্যান্ডার্ড, তখন হচ্ছে আপনার নেটওয়ার্ক অপারেটর গুলো হচ্ছে তারা বাধ্য, নেটওয়ার্ক অপারেটর এবং হচ্ছে সেলুলার ডিভাইস ভেন্ডর যারা ম্যানুফ্যাকচারার, ফর এক্সাম্পল কোয়ালকম অথবা ইন্টেল, there are the two main developers or manufacturers for the cellular modem. তারা হচ্ছে এই সলিউশনগুলো ইনকর্পোরেট করবে, প্যাচ পাঠাবে। এখন যেটা হচ্ছে যে যারা ওইএম ম্যানুফ্যাকচারার যেমন হচ্ছে অ্যাপল, এখন এই জিনিসগুলো হচ্ছে অনেক সাপ্লাই চেইনের ব্যাপার আছে। তো কে ইনকর্পোরেট করবে? ফার্স্ট অফ অল কোয়ালকমে মেক শিওর করা লাগবে যে দিস উইল বি ইনকর্পোরেটেড ইন দেয়ার কাইন্ড অফ এক্সিস্টিং মডেমস। দেন হচ্ছে কোয়ালকম অলসো মেক শিওর করবে অ্যাপলকে যে আমার এই আপডেটটা ওভার দি এয়ার আপডেট, এই প্যাচটা পাঠাইতে হবে। সো মানে এটা বোথ কাইন্ড অফ কোলাবোরেশন বিটুইন কোয়ালকম হু ইজ দি ম্যানুফ্যাকচারার অ্যান্ড ওইএম যারা হচ্ছে অ্যাপল, যারা হচ্ছে এসওসি এ করতেছে, ডিজাইন করতেছে। তো হচ্ছে আপনার কাইন্ড অফ ইটস হার্ড টু মেক শিওর যে আপনার ভালনারেবিলিটি গুলো নাই। ইনফ্যাক্ট যদি 3Gর কথায় আসি, বাংলাদেশে যে এখনো যদি 3G বা 2G চলে, 3G inherently vulnerable. I mean, vulnerable to man in the middle attack. So, I mean, 3G, 2G out of consideration. In my opinion, I mean,
সবচেয়ে বেশি ভালনারেবল আর কি, কারণ আমাদের দেশে ধরো যে ঢাকা শহর বাদ দিলে, মানে যদি ঢাকার বাইরে যাই তাহলে তো মানে 3Gও মানে অনেক সময় মেইনলি সিচুয়েশন না। কারণ আমি আসলে এক সময় দেখতাম, কারণ মানে বেশ 1 বছর আগেও মাত্র বাংলাদেশের বোধহয় 10% হ্যান্ডসেট ছিল 4G এনেবলড, ঠিক আছে, মানে ওভারঅল মানে জিপি নেটওয়ার্কে ছিল, ঠিক আছে, 10% সেট 4G এনেবলড, বাকি সবই ছিল মানে 3G এন্ড বিলো আর কি।
রাইট। মানে 3G 4G
তুমি যে টুলটা দেখালা, মানে এটা তো মানে এখন কিন্তু হ্যান্ডসেটেও মানে লিনাক্স কার্নেল পাওয়া যায়, অ্যান্ড্রয়েড হ্যান্ডসেট। হ্যাঁ, এখন তুমি যে কমান্ড গুলো দিচ্ছ ওইটা কি আমি, কারণ আমার হ্যান্ডসেট তো একটা ইউই মানে একটা মোবাইল ডিভাইস, তো আমি কি এখান থেকে কমান্ড দিয়ে আমি তুমি যে হ্যাকিং গুলো দেখালা সেগুলো আমি করতে পারি না? কারণ তাহলে যেটা হচ্ছে কি, মানে এই জিনিসগুলো একদম গ্রাম বাংলায় পৌঁছে গেল আর কি, যে পুরো হ্যাকিং টুলস এন্ড দ্য হোল মানে কি বলা যায় মানে ভিকটিমস তারা এক জায়গায় আর কি।
আসলে হ্যাঁ, এটা গুড কোয়েশ্চেন ভাই, যে আপনার যেহেতু লিনাক্স অ্যাভেলেবল, আসলে সব জায়গায় লিনাক্স অ্যাভেলেবল না, বাট টু বি অনেস্ট মানে আমরা যেটা ফেস করছি যখন আমরা এই কাজগুলো শুরু করছি, ওয়ান অফ দি মেইন চ্যালেঞ্জেস ওয়াজ creating the test bed, like how we can validate all these problems. তো সেলুলার নেটওয়ার্কের একটা বড় চ্যালেঞ্জ হচ্ছে যে আপনি কোনো লাইসেন্সড স্পেকট্রামে কোনো প্যাকেট ইনজেক্ট করতে পারবেন না। তো ধরেন আমি টি মোবাইল বা AT&T নেটওয়ার্ক টেস্ট করতে যাচ্ছি, তো ডিভাইস যদিও ধরেন ডিভাইসে AT&T সিম কার্ড আছে, বাট legally I'm not entitled to send or inject any packet to the device or in the network side. তো ওইটা হচ্ছে খুবই চ্যালেঞ্জিং ছিল আমাদের কাছে। তো এর জন্য আমাদের যেটা করতে হয় যে কাইন্ড অফ ফ্যারাডে কেজ টাইপ ডিভাইস ইউজ করতে হয়, যাতে আপনার সিগন্যাল কখনোই আপনার টেস্ট বেডের বাইরে যেতে না পারে। তো ডিফারেন্ট ভার্সন আছে আসলে ফ্যারাডে কেজ বানানোর, লজিক্যালি বানানো যায় অথবা ফিজিক্যাল কোনো কেজ দিয়ে আসলে বানানো যায়। আর টেস্টিং যদি বলেন যে টু মেক দি টেস্ট অ্যাভেলেবল ফর অল দি পাবলিক, আই মিন ইভেন ফর দি remote places, of course this is possible, kind of একটা এরকম যে সফটওয়্যার ডিফাইন্ড রেডিও পেরিফেরাল যেগুলো আছে, ইউএসআরপি বোর্ড, এগুলো এখন খুবই চিপ। অলসো লিনাক্স ফোন যেগুলো আছে বাজারে সেটা দিয়ে হয়তো বা করা যায়, আমি জানি না আসলে। Even though Linux phone they use Linux operating system, but they are general purpose operating system. So baseband processor they have different operating system, like they use ARM, or I mean based on ARM they use different, like since they have two different processors, it's not about just Linux phone have access to the cellular modems. It's not like that. So I mean যেটা বলছেন ভাইয়া যে সেটা হচ্ছে যে with just Linux phones, I mean, probably it's not something like that. It would be readily available for testing for any people.
আচ্ছা আচ্ছা, তাও ভালো, ভেরি গুড। কারণ বাংলাদেশে তো আসলে তুমি যেটা বললা যে এটি নেটওয়ার্কে প্যাকেট তুমি ইনজেক্ট করতে পারবো না, সেটা তো বাই ল আসলে এই ধরনের কোনো ল আই থিংক বাংলাদেশে নাই আর কি।
Probably আসলে টু বি অনেস্ট যদি লাইসেন্স স্পেকট্রাম থাকে, আমি জানি না আসলে রুলস এন্ড রেগুলেশন, মানে এটা ঠিক না আসলে আপনি কোনো প্যাকেট ইনজেক্ট করবেন লাইসেন্স স্পেকট্রামে, এটা লিগালি ইনকারেক্ট। তো
অবশ্যই
তো যার কারণে এটা একটা ছিল যেরকম আমরা সোফার, আমি বলবো যে আমাদের কাজের আগে কিছু প্রিভিয়াস কাজ হয়েছে যেটা দেখাইছে যে মানে আমাদের অ্যাজাম্পশন ছিল যে সেলুলার নেটওয়ার্ক হচ্ছে ফুল প্রুফ, there is no kind of vulnerability there. We took it as granted, but there are so many vulnerabilities, there are so many problems in cellular networks that we can't imagine. I mean, there are a lot of opportunities.
তুমি একটু অবাক হয়েছিল রাফিউল, কারণ তুমি রিসেন্টলি তুমি যদি দেখো মানে টেলিকম ভেন্ডর গুলা আইওটি তে মুভ করতেছে এবং তাদের অ্যাডভার্টাইজমেন্ট যদি দেখো, সেই অ্যাডভার্টাইজমেন্টে দেখবা তাদের মেইন ফিচার ইজ देयर সিকিউরিটি। ঠিক আছে, এখন তুমি যেগুলো দেখালে এগুলো তো মানে আই ওপেনিং আর কি। ঠিক আছে, মানে আমার আইডিয়া ছিল না ফ্র্যাঙ্কলি স্পিকিং। মানে আইওটি কিন্তু অনেক ভাবে করা যায়, মানে ধরো যে ইভেন মানে ওয়াইফাই না হলো আর যে লো ব্যান্ডউইথের কিছু নেটওয়ার্ক আছে ওগুলোতে আইওটি করা যায়, জানি না তো ভালো। কিন্তু তারা মানে এরিকসন হুয়াই এরা এখন ওদের নিজস্ব মানে অফিস বেজ স্টেশন মানে ফর আইওটি এরকম নিয়ে আসতেছে এবং বলতেছে যে মেইন ফিচার ইজ দ্য সিকিউরিটি।
রাইট, আই মিন connected vehicles. I mean, এখন যে আসলে এদের cellular IoT is the big thing. All আপনি যেটা বলছেন ইফতি ভাই যে all these cellular networks are kind of moving towards IoT and connected vehicles, smart cities. মানে cellular network is the next big thing for them. I mean, they need some kind of secure or stable connection. Wi-Fi kind of, this is for short range communication. For long range communication, they need something like cellular networks. তো এটা একটা আসলে মেইন কনসার্ন তাদের হচ্ছে মেক শিওর দ্বারা করা যে সিকিউরিটি, কারণ আইওটি ইজ কমপ্লিটলি ব্রোকেন, মেসড আপ, অ্যান্ড এখন যদি সেটা ইনকর্পোরেট হয় আপনার হচ্ছে সেলুলার নেটওয়ার্কের সাথে, which is also vulnerable, then we are doomed sort of. There is a question in the chat.
না আমি কারো কোশ্চেন থাকলে, মানে আমরা কিন্তু বেশ কয়েকটা, তোমার টকটা ইন্টারেস্টিং, আমরা বেশ কয়েকটা সিকিউরিটি টক শুনছি এবার আমাদের এই লেকচার সিরিজে, বাট এই তোমারটাই কাইন্ড অফ প্রথম যেটা একটু এই যে মানে এই ইয়া নিয়ে কাজ করতেছে আর কি।
আচ্ছা,
মানে এই সেলুলার ইয়া নিয়ে কাজ করতেছে, যেটা ইন্টারেস্টিং। মানে সবাই অ্যাটলিস্ট সিকিউরিটি বা নেট না যাই বুঝুক, সেলুলারের এই জিনিসপত্রগুলা খুব ভালো মতো বুঝে আর কি। আচ্ছা, কারো কোনো কোয়েশ্চেন থাকলে করে ফেলো। কেউ নাই কোয়েশ্চেন? আমাদের এই এসিএম চ্যাপ্টারে মাহমুদা ম্যাডাম হলো প্রেসিডেন্ট। ওই যে ম্যাডাম অন্য একটা মিটিং এ বিজি আছে, ম্যাডাম নরমালি আসে সব সময়।
আচ্ছা,
ইমতিয়াজের কোনো কোয়েশ্চেন নাই? কোনো কোয়েশ্চেন, কোনো কমেন্টস?
না স্যার, আমার তেমন কোনো কোয়েশ্চেন নেই আপাতত।
ইমতিয়াজ কি নিয়ে কাজ করো? এগুলারই কোনো এক্সটেনশন বা ডিফারেন্ট এরিয়া?
আমি কাইন্ড অফ এটারই সেলুলার নেটওয়ার্ক, মোবাইল সিস্টেম, এগুলার এক্সটেনশন নিয়ে কাজ করছি। মানে আমাদের রিসার্চ এরিয়া কাইন্ড অফ সিমিলার। মানে ভাইয়া এটা শুরু করেছিলেন, আমি এটাকে আর কি ফলো থ্রু করার চেষ্টা করছি।
হ্যাঁ, ইমতিয়াজ এগুলা নিয়েই কাজ করতেছে। ওর সাথে আসলে আমার প্রতিদিনই মোটামুটি মিটিং হয়, কথা হয়। স্পেসিফিক্যালি যেটা
ভালো কাজ করতেছে, তাই না? খুবই ভালো আউটপুট কম সময়ের মধ্যে, খুবই ভালো।
যে থার্ড কাজটা যে আমি যেটা প্রেজেন্ট করলাম, ATFuzzer, এটা ও লিড অথর, ওই কাজ প্রজেক্টটাতে লিড দিছে, খুবই ভালো কাজ করছে। ইভেনচুয়ালি ইট ওয়াজ গট দি বেস্ট পেপার অ্যাওয়ার্ড। তো ফার্স্ট ইয়ারে থেকে বেস্ট পেপার অ্যাওয়ার্ড পাওয়া সামথিং কাইন্ড অফ এক্সট্রাঅর্ডিনারি।
সিকিউরিটিতে আমাদের আসলে বেশ ভালো কাজ করতেছে। যে আমাদের 06 ব্যাচের একটা ছেলে অ্যালুমনাই ছিল, সাজ্জাদ হলো ভার্জিনিয়া টেক থেকে পিএইচডি করে এখন অ্যারিজোনা ইউনিভার্সিটি অফ অ্যারিজোনায় মনে জয়েন করতেছে। সাজ্জাদ তো দেখলাম সিকিউরিটিতে, ও হয়তো বা তোমার এরিয়ায় না, ও হলো ওই যে প্রোগ্রামিং ল্যাঙ্গুয়েজ ওই টাইপের, ওই জাভা টাভা ওইসব সিকিউরিটি গুলো নিয়ে কাজ করে। বাট হ্যাঁ, খুব ভালো, মানে খুব ভালো ইয়া। কারণ কনফারেন্স গুলো দেখলেই তো বোঝা যায় যে মানে ওগুলা গুড ওয়ার্ক, তাই না?
রাইট। হ্যাঁ, সাজ্জাদ বেশ ভালো কাজ করতেছে।
আমাদের ইয়াও কাজ করে এটাই, অনুপমও সিকিউরিটি নিয়ে কাজ করতেছে। ফাইন, মানে আমাদের একটা ভালো সিকিউরিটি অ্যালুমনাই ইয়া তৈরি হয়েছে।
জি।
হ্যাঁ,
আমি
বেশ
স্যার এটা বলতে
বাড়তেছে।
চাই আর কি যে আমি এই যে ফার্স্ট ইয়ারে এত কাজ বা এটার জন্য রাফি ভাইয়ের মেন্টরশিপ অনেক ইম্পর্টেন্ট ছিল। তাই আমি হচ্ছে প্রসপেক্টিভ স্টুডেন্টদেরও বলতে চাই যে যারা অ্যাপ্লাই করতে চায় ফিল ফ্রি টু অ্যাপ্লাই।
হ্যাঁ হ্যাঁ হ্যাঁ,
ভাইয়া অসাম মেন্টর, অনেক খাওয়াবে, অনেক কাজ করাবে, কিন্তু এট দ্য এন্ড অফ দ্য ডে একদম আপন বড় ভাইয়ের মতো ধরে কাজ করাবে।
এক্স্যাক্টলি, মানে আমি তো ওটাই বলতেছিলাম রাফিউলের যে 7 এ রাফিউল আমি একই হাউসে ছিলাম, ঠিক আছে, মানে
একই রুমেও ছিলাম ভাই।
একই রুমেও বেশ করেছিলাম। মানে আমি ওর ডেডিকেশন এবং মানে ওর হার্ড ওয়ার্কের ইয়াগুলো আমি নিজের থেকে দেখছি অনেকদিন। সো এটা সবার জন্যই, মানে যারা সিকিউরিটির এই লাইনে কাজ করতে চাও তাদের জন্য
হ্যাঁ,
অবশ্যই তোমরা রাফিউলের কাছে মানে
থ্যাংক ইউ
সিরিয়াসলি
ভাই,
যদি
থ্যাংক
কাজ
ইউ।
করতে চাও অবশ্যই
হ্যাঁ,
রাফিউলের সাথে ইয়ে করতে পারো।
থ্যাংক
যে
ইউ।
আমি বলবো যে কাজ ছাড়া যদি খাওয়া দাওয়াটাও ইন্টারেস্ট থাকে তাহলেও যাতে ভাইয়ের সাথে যোগাযোগ করে। আমি আসার পরে 1.5 বছর ভাই আর আপুর বাসায় গিয়ে সারাদিন খেতাম। তাই এটা একটা বড় অপরচুনিটি কাজ ছাড়াও খাওয়া দাওয়ার ক্ষেত্রেও, কারণ গ্রাজুয়েট স্টুডেন্ট তো এমনি খাবার পায় না। আসার পরে হচ্ছে প্রথম
আর
কয়েকদিন
তোমাদের পারডুতে যে খুব একটা রেস্টুরেন্ট আছে তাও না,
কিছুই নাই। স্যার ঠিকই বলছেন, আসলে কিছু নাই।
একটা বাংলা রেস্টুরেন্ট ছিল,
এখন আর নাই স্যার, এখন কিছুই নাই। এখন
আমরা রাফিউল সহ আমরা ওইটাই বুফে খাইতে গেছিলাম, আমার মনে আছে।